G'day, I'm Leschev. Besides being married with 3 kids that don't behave themselves unless they're asleep, I work for a company called Atlassian, makers of developer tools. Some of our products include Jira, Confluence, Bamboo, Vagrant and Stash. I'm the team lead at Build Engineering, and I'm going to talk to you today about the great work that my team's been doing over the past 3 years. I'm going to say it's an absolute privilege to work with such a great team. The team is responsible for providing a build platform and services that's used across the whole organisation. Being a software house, there's a huge appetite for CI capacity. To give you an idea of the scale that we operate in, we're running 60,000 builds per month. Jira itself has 35,000 automated tests. That doesn't include scenarios where we run those tests multiple times across different platforms, like MySQL, Postgres, Windows. Developers expect a reliable infrastructure and fast CI feedback. They want to deliver features quickly and safely. When a build fails, they want to trust the results that they receive. They don't want to be slowed down by unreliable infrastructure. In terms of build infrastructure today, we have 600 build agents, a combination of our own hardware running long-running agents, and we also spin up AWS Elastic instances on demand. Our build agents require a large amount of configuration for them to get into a state to perform builds successfully. To cater for the various teams across the whole organisation, we need to install various SCM clients like Git Material, Subversion, various versions of the JDKs, JVM build tools like SBT, Maven, Ant, databases like MySQL, Postgres, Oracle, being able to support headless browser testing, Firefox and Chrome, being able to do Python and Node.js builds, and being able to generate installs of our products as well. And then we have to deal with the credentials and all the configuration that goes with that. We maintain about 20 AMIs of various permutations of our build configuration. Given that Atlassian dog foods its products internally, all the product teams use Bamboo, Atlassian's continuous integration server, which allows you to build, test, and deploy your code. We're running 6 instances of Bamboo internally, beyond the publicly supported limits of Bamboo agents. We also run the Maven infrastructure, including maven.atlassian.com, which is 6 Nexus instances under the covers. Then all the monitoring that comes with that. Atlassian's expanding at a rapid rate, so providing this ever-growing platform continues to be a challenging problem. What does it mean to be practicing infrastructure as code? Just as a show of hands, who's using Puppet here? Great, I'm at the right conference. Does using Puppet and having your Puppet code checked into source control enough to tick the buzzword checkbox? I believe it's just the beginning. And I'll take you through the challenges that the team faced and the practices that we implemented as we went along our journey. 3 years ago, we were manually maintaining snowflakes. These were machines in an unknown configuration state that would be extremely difficult to rebuild from scratch. And we started using Puppet. A developer requested a new version of the JDK to be installed on all the agents, and we went to roll that out. We pushed the change, and it broke all the build agents that were under Puppet control at the time. The change didn't just reduce the CI capacity of the small build group that we had at the time. The dodgy push resulted in every build failing on those agents. We were providing a platform that was producing build failures that were infrastructure related. This is not the situation we ever want to be in. Developers have a hard enough time getting their automated tests to run in a reliable manner without any flakiness, let alone having infra-failures come and spoil the party. We can live with a reduced CI capacity, but that CI capacity needs to work. To make matters worse, the rest of the team wasn't aware that a change was being pushed out and what that change was. We had a problem. We had a low confidence of change. We weren't confident that the change would be, we weren't confident that the change would work, and we weren't confident that it would break anything else. If you think about the infra change over time being developed and rolled out, we had very little confidence that it would be successful until it hit production. Even then, we weren't very confident. It's obviously a very subjective graph with lots of hindsight bias associated to it, but please bear with me. I was scared when Puppet changes would go out, but I wanted something better than this. I wanted to know about the failures before they hit production and impacted the developer build results. As a show of hands, who's still using Subversion here? Oh, you poor bastards. One of the first improvements that the team made was the move from Subversion to Git. We moved our code to Bitbucket and started using pull requests as a lightweight code review tool. By using pull requests, it encourages the team to create smaller, more manageable chunks of change. It encourages peer review and the team talking about their code, which results in an increase in code quality. We started a team convention of obtaining 2 improvers before merging to master. Then we started getting comments pointing out style issues coming up with pull requests. This is something that can be automated. Humans need to think about higher level problems than worrying about coding style. So Tim Sharp has written a tool that performs automated style checking of public code. Thanks, Tim. You're up there. We set up a Bamboo build that runs the checks and posts the results. But we still need to set up a ratchet build that fails the build if the number of errors or warnings goes up, because we haven't got the warning count down to 0 yet. Because we added the code review process, it gave us more confidence in change. Another area of improvement was our use of our Puppet staging environment. We were using a handful of agents in a Puppet staging environment to develop our changes on them. We'd make manual changes on those agents and then puppetize those changes by hacking away at the Puppet master. This caused staging machines to drift off actual Puppet configuration, as not all manual changes made it back into Puppet. And it promoted a culture of modifying production instances manually and not keeping everything in Puppet. This goes totally against our need for a consistent build environment. Every agent needs to be the same, so when a build fails, it's not attributed to differences between the agents. Rebuilding the build agents from scratch at the time was non-trivial, so it was very rarely done. These machines were still being used for production, as this was our only way at the time to validate whether the changes were successful. And unfortunately, at times they weren't. So, as a show of hands, who's using Vagrant here? Wow, okay, that's very cool. Michio Hashimoto has written a tool called Vagrant, which allows you to spin up your infrastructure quickly and easily on your laptop. Handles the complexity of configuring the VMs, including the networking and the shared folders between the guest and host VMs. Comes with a plugin framework that allows you to extend the provided functionality. It allows you to create disposable, reusable environments. So the machine provisioning is done by VirtualBox, VMware, AWS, and the configuration can be applied via shell scripts coupled with Leschev. Allows you to start with a known configuration state, develop and test your changes locally before checking into SCM. So to spin up a VM, Bamboo agent in this example. You can run Vagrant up from your command line. A Vagrant file, which contains the configuration that describes the type of machine and how to configure and provision it, is ready. This file is checked into source control together with your project so that everyone is developing from the same known state. The Vagrant base box, or box, is required as well. It's a platform-independent bare machine that Vagrant uses as its starting point for its provisioning process. So you can check out the source control of your project, run Vagrant up, and it'll bring the VM to its known state. You can make some public changes in your favorite editor, run Vagrant provision, which then runs public apply within the VM. You can add SSH into the VM and confirm that the changes are successful. After you've committed your changes to SCM, you can then destroy your VM. It's that simple. We started using Vagrant about 2.5 years ago. We're still using the VirtualBox provider. It comes with a number of advantages. There's no need to use the real agents. You can actually use your staging environment as a staging environment instead of developing changes on it. And there's a lot less risk of configuration drift. I just want to give a big thank you and shout out to Mitchell Hashimoto. My team wouldn't be able to function without your contributions to open source, so thank you very much. Because the team started to develop their changes locally using Vagrant, not only significantly improved the confidence level of our changes, but it also improved the confidence early on in the change process. We find out about problems sooner rather than later. As we started to use Vagrant, we noticed differences between Vagrant and our production machines. The biggest difference was between the Vagrant base box and the bare machine or VM being provisioned in production. We were using publicly available Vagrant base boxes which had differences in the packages that were installed. Unfortunately, generating a base box manually was a painful process. A couple of years ago, we started to use VWare, a tool written by Patrick Dubois, which automates the process of building custom Vagrant base boxes and other VM images. In a fully automated manner, it takes a configuration file, downloads the required ISO, spins up VirtualBox, performs an OS installation, installs all the Vagrant dependencies and configuration. Most importantly, it also tests that the base box is generated successfully using automated tests. VWare supports more than Ubuntu. I'm just using it as an example here. So here are some screenshots of it in action. Install, running automated tests. We moved the generation of the Vagrant base box into a Bamboo build. This is to ensure that we have an up-to-date base box that is made available to the team for their local development. By putting this process in a build, it also ensures that it's a repeatable process, and we receive notification when it starts to fail. For example, if an external package is no longer available. We'll find out about it immediately, instead of when we discover we need to rebuild the base box. There are still some differences though, between production and Vagrant for us. We still need to install the VirtualBox guest editions for our Vagrant instances, but we've managed to keep those differences to a minimum. So we could get VWare to generate a base box for us in an automated manner, but more recently, we had a broader problem. We had multiple pre-seed and post-install files that were used for different scenarios. We were generating a base box for Vagrant. We needed them for our PixieBoot process. And we're also embedding them into custom ISOs that we're generating to provision certain machines that couldn't be PixieBooted. We started by moving all the variations of these files into one location of our Puppet tree. And then by using Puppet templates, remove the duplication of configuration across the different files. Michio Hashimoto has more recently released a tool similar to VWare called Packer, we started to use this for Windows AMI generation. But we haven't used it for just more than that just yet. We have a homegrown solution for AMI provisioning, which we haven't thrown away and replaced with Packer yet. Because we started to use VWIP to generate our base box, bringing it closer to production, it gives us slightly more confidence of change earlier on in the infra change lifecycle. So we're developing our changes locally using Vagrant, using staging as an actual staging environment, rolling out to production, but we're still getting broken build agents. We're getting regressions. We especially notice this when we go to provision new instances of the build agents. While developing our changes, we manually make changes to the VM, SSH in, poke around, make sure it's what we'd expect, then we'll go to publicize it and check again. But we didn't have any confirmation that we'd broken anything else in the meantime. So we started using Cucumber and behavior-driven development, which focuses on asserting the expected behavior of the system rather than how it's configured. For example, we confirm that a particular command line tool that we require as part of our build is working, rather than asserting that the actual package is installed. Or another example is a test that confirms that the Nexus web front end is reporting that it's correctly licensed, as opposed to checking the presence of the license file in the system. So to practice BDD, you write the test of what you would expect, run the test initially to see it fail, then write some public code, apply that public code, and rerun the test, and watch it go green. It allows for automated testing of changes locally within Vagrant. To hook our Cucumber tests into Vagrant, we wrote our own custom Vagrant provisioner plugin, which on provision would run Puppet apply and all the Cucumber tests over SSH as part of the provision step. So every time Puppet runs in Vagrant, we get confirmation that all our regression tests pass. This does come with a couple of disadvantages. It requires the Cucumber dependencies to be installed on the tested VM. It's not necessarily what you want. And since the tests are run within the VM, it makes testing certain scenarios harder, like firewall rules. Because we added behavior-driven development to our change process by introducing Cucumber, we significantly improved the confidence level of our changes. And then I heard this in the team. So we started to provision our infrastructure from a bamboo build. We performed from scratch provisioning, i.e. starting from a bare Vagrant base box and running Puppet apply, and then running all the Cucumber tests. This gives us confidence in not only sorting out integration issues between members of the team, but also confidence that we can rebuild in a disaster situation. If there's a problem with the provisioning process, you'll find out about it immediately and not during your disaster. Which brings me to a quote from Tim Bell of CERN, who in his PuppetConf 2012 keynote defined two categories, pets and cattle. By being able to reprovision your infrastructure easily and quickly from scratch, it allows you to treat your machines like cattle instead of pets. If your machine starts misbehaving, you have the option of destroying and rebuilding from scratch without wasting your time nursing your pet back to health. You can also make sure that machine configuration doesn't drift over time by shooting your cattle regularly. It's fine if you try. This is especially important for consistency across all the build agents. So by adding continuous integration to our Puppet infra change lifecycle, we significantly improved our confidence of change. The next problem that we had was that from scratch provisioning was slow. We started by spreading out the provisioning process from a sequential order to parallelizing it across multiple Bamboo jobs. The benefit of this approach was that it not only reduced the overall provisioning time, but it also highlighted unintended dependencies between the VMs. Which led us to the next problem, finding enough machines to run our Puppet CI on. And these are the machines in the storeroom which I've got my eyes on. But seriously, building a Mac Pro grid wasn't an option, so we had to look elsewhere. We started by profiling our Puppet runs. We did this by updating our custom Vagrant provisioner to pass the eval trace option to the Puppet apply call and collect and show the log messages with the longest messages, or the longest times. Similar to running our Cucumber tests, we profile our Puppet runs with every Vagrant provision. So it highlights problems a lot sooner during the development of the changes rather than later on. We also added profiling of our Cucumber tests, allowing us to concentrate on improving the longest running tests. It also allows you to question the value of those long running tests. Is it really worth it? And you can go to that URL and copy and paste the code that we copied and pasted to get that same functionality. So that wasn't enough. That wasn't enough. So we introduced a concept called delta provisioning. So as part of the CI builds, we would export successfully provisioned VMs to a file share, and then use that same export as a starting point for delta provisioning. In this way, Puppet only has to apply the small difference of changes rather than going through the long process of provisioning from scratch. We've set up our Vagrant file in such a way by providing an environment variable, the correct base box is downloaded for either from scratch or delta provisioning. It significantly decreased the time it takes for people to bring their laptops up to the last known good state, ready for them to develop their changes on. It also picks up a different class of problem. For example, you might be able to provision a machine from scratch successfully, but applying that same Puppet configuration to an already provisioned VM might fail. Delta provisioning picks this problem up. This is important as this approach more closely matches production and provides us more confidence that our changes will be successfully rolled out. So by adding delta provisioning, it gives us more confidence in change later on in the change lifecycle. We use Kanban within the team to visualize our work. By putting limits in place, we can quickly identify bottlenecks in our flow. We noticed a bottleneck in our rollout process. It was due to infrequent releases of our Puppet changes, which resulted in larger changes being rolled out. With that comes larger failures. The infrequent releases were due to Puppet rollouts being painful, so the team would batch them up. The main cause of the pain was that Puppet runs would impact running builds. If a build agent was changed during a Puppet run, the service would be restarted, causing any currently running build to fail. So to avoid this, the team would disable the build agents within Bamboo, disable Puppet on all those agents, perform the rollout by doing a git clone, librarian Puppet, install Simwin Puppet Data Master, manually kick off Puppet on all those build agents, confirm that it worked, then enable the build agents back in Bamboo, and also enable Puppet on those agents. To make matters worse, we had a Puppet environment for each Bamboo server, so these steps had to be repeated multiple times. The problem was that the notifiers of our file resources, which would force a restart of the service, when Puppet runs and changes the file resource, it tells daemon tools to restart the service, killing any currently running build. To solve this problem, we changed the service definition of our Bamboo agent to create a touch file when it needed to restart, instead of actually restarting the service as part of the Puppet run. And we wrote a Bamboo plugin to watch for this touch file and gracefully shut down when it came to an idle state. What I like about this approach is that it only requires a service definition change. References to notify don't require changing. There's no need for anyone in the future to think about doing anything special to get graceful restarts to work when writing a file resource. They just need to continue to use the standard approach of calling notify. With the introduction of the graceful restarts, we no longer had the need for a separate Puppet environment for each Bamboo server. We were able to have one staging and one production environment. But we're still manually updating the Puppet tree and the Puppet master. So going through all those steps, still painful. So we created a Bamboo build which performs those steps automatically. The staging symlink is updated automatically when all our tests go green. And the production symlink is a manual staging Bamboo that can be kicked off by a click of a button when we're ready to deploy to production. This was especially useful when we were performing a data center migration where we had to keep multiple Puppet masters in sync. So with less human interaction and more automation, we gain higher confidence until things go wrong. With less human effort, there's an increase of release frequency. With the addition of more frequent releases, we gain more confidence of change. Three years ago, I was scared of Puppet changes. I was scared of them being rolled out. But more recently, I caught myself thinking, should I be scared? Given that we've added all these tools and processes to improve our confidence, I shouldn't be. To get over this irrational thought, we added HipChat notification. So that whenever we deploy to production, we get a message in our HipChat room, or the team's HipChat room, that a deploy has been done. We also get a link to a different changes that have gone out, so we can quickly assess the risk of the change being pushed to production. So when things do go wrong, we can quickly go back to this diff and determine what the problem is. By adding notification, it gives us more confidence of change in the rollout process. So when we first started, we had a very low confidence of change. So all the tools and processes we added, we improved our confidence level of change. What's important here is that we've not only significantly improved our level of confidence, but we've gained that confidence early on in the change process. Change of confidence, or finding and fixing problems sooner rather than later. I want to know about problems and failures before they hit production and impact developer build results. Besides not impacting developer builds, why is this important? We've got a commit graph of our Puppet tree, number of commits in blue, and the number of kickover tests that we have in red. Started 2003, where you see that huge spike. We had a data center migration, and we've had a sustained pace since then. I can comfortably say that without all the things that we've put in place, that migration and the sustained pace wouldn't have been possible. So over time, we've made the transition from machines that were snowflakes in an unknown configuration state to pets that were under public control, to cattle that can be rebuilt from scratch. The next phase that we're currently working on is the move to stateless machines. At the moment, we're running long-running build agents, so we get hit by misbehaving builds, impacting subsequent builds running on that same agent. What we're currently working on is using Docker to create and destroy containers on a per-build basis to ensure that each build starts in a known configuration state. So the build can run in its own little universe, isolated from everything else. So we're still on the journey. If any of this interests you, love to have you on board. So come and chat to me afterwards or hit Atlassian.com/jobs. Thank you very much. Any questions?
Any questions? How many people in this build engineering team?
8 or 9 including me. But that's, I guess we've got a combination of infra and developers. So there's 3 infra, the developers get involved as well.
Any other questions? Great, thank you. Oh, well, I saw one down here. Hold on, hand go up. Yep.
So you're really maintaining just one build configuration on your build agents?
No, so for the long-running agents, we've got a set of long-running agents, and then elastic instances that are spun up on demand. What we try to do is get as much of the configuration on those long-running agents, so that when builds get queued, they can run on those builds, on those build agents. But there are various permutations of versions of Postgres, MySQL, Oracle that we need to use AWS to run them on at the moment. But when we move to Docker, it'll be one image or a number of images that would be spun up on a per build basis.
So in the development stage, do you actually have different people with different configurations to be able to test their changes? Or do they just use the one all the time and then push it out to staging and hope that it gets picked up there?
So for the long-running agent, we use Vagrant to develop our changes in. I guess we've got a different setup for AMI provisioning. We are using public for that. So we spin up an AWS instance, copy the public tree over on public, and then burn the image in an automated fashion. So when we're developing the AMIs, we're actually spinning up the AMIs, running public on AWS to develop our changes on it. So to try and answer your question, within Vagrant, we're doing the development of the long-running instances.
Do you have Windows build agents?
Yes, we do, and the team tends to quit every time they have to work on it.
What's your plans for Windows and Docker and?
Well, we can't with Docker, right?
Right.
So,
Yeah.
We have to stick with the AMI provisioning process that we have, and it's unfortunate. We won't be able to have the sort of per build instances for Docker that we'd like. We've got a script that runs before and after each build that tries to clean up state that we want to get rid of as part of the move to Docker, but that's something we'll have to still keep in the list. It's not a solved problem.
Can you just describe the Docker stuff, like what that's going to do? Just briefly. I don't know what Docker does.
Docker, so it's like LC with image-based machines. guess it allows you to spin up a configuration quickly for a particular build. At the moment, we've got a lot of configuration installed to handle as many builds as possible, but we'll be able to move to images with a lot less configuration, just the configuration that you need for that build. So we won't need MongoDB to be running for 95% of our builds.
When you use a cucumber, and who will develop the user story and define the acceptance criteria?
Sorry, what was the question?
When you use a cucumber, so who will develop the user stories and define the user acceptance criteria?
So we use it as a regression tool within the team. We don't. You could think of it as the contract of what we provide as a build agent to the rest of the development teams, and they could come and define the user acceptance test, but we don't really use it in that way. We just use it as a regression tool within the team.